Graph Data Structure Part 1. Adjacency Matrix. Adjacency matrix.
An adjacency matrix is a way of representing a graph as a matrix of booleans, zeros and ones. A finite graph can be represented in the form of a square matrix on a computer, where the Boolean value of the matrix indicates if there is a direct path between two vertices. Each cell in the above table or matrix is represented as Aij, where I and j are vertices. The value of Aij is either 1 or 0 depending on whether there is an edge from vertex I to vertex j.
Undirected graph. Matrix representation of the graph.
If there is a path from I to j, then the value of Aij is 1, otherwise it's 0. For instance, there is a path from vertex 1 to vertex 2, so A12 is 1, and there is no path from vertex 1 to 3, so A13 is 0. In case of undirected graphs, the matrix is symmetric about the diagonal because of every edge, I, j, there is also an edge, j, I.
Directed graph.
If there is a path from j to I, then the value of Aj is 1, otherwise it's 0. There is a path from vertex 0 to vertex 1 and 2, so A01 and A02 are 1. There is no path from vertex 1 to any vertex, so there are 0. Then, a path from vertex 2 to vertex 1, so A21 is 1. Finally, a path from vertex 3 to vertex 1, so A31 is 1.
Pros of adjacency matrix.
The basic operations like adding an edge, removing an edge, and checking whether there is an edge from vertex I to vertex j are extremely time-efficient, constant-time operations. If the graph is dense and the number of edges is large, an adjacency matrix should be the first choice. Even if the graph and the adjacency matrix is sparse, we can represent it using data structures for sparse matrices. The biggest advantage, however, comes from the use of matrices. The recent advances in hardware enable us to perform even expensive matrix operations on the GPU. By performing operations on the adjacent matrix, we can get important insights into the nature of the graph and the relationship between its vertices.
Cons of adjacency matrix.
The space requirement of the adjacency matrix makes it a memory hog. Graphs out in the wild usually don't have too many connections, and this is the major reason why adjacency lists are the better choice for most tasks. While basic operations are easy, operations like in edges and out edges are expensive when using the adjacency matrix representation.
Adjacency matrix code in Java.
First, create class graph. Rows and columns of adjacency matrix. Number of the vertices. Initialize the matrix. Add edges and remove edges. Print the matrix. Here, input the number of vertices of graph. Here, can add or remove any edges of the graph. Finally, the code print out the matrix. Finally, print out this result. The code is add edge 0, 1. The code is add edge 0, 2. The code is add edge 1, 2. The code is add edge 2, 0. The code is add edge 2, 3. It is undirected graph, so the matrix is symmetric.